Hello, welcome to Matrix Uploaded. This is Life Sciences. I'm Helen de Wet, and today we're going to be looking at organic molecules. Thousands of years ago, the ancient Greeks wondered what would happen if you took a substance and if you divided it and then carried on dividing it and divided it into smaller and smaller pieces. Would there come a time where you couldn't divide the piece into anything smaller? And they concluded that all matter was made up of minute particles that were ultimately indivisible. They had no evidence for this, of course. But over the thousands of years, scientists have established that matter is made up of minute particles, and they call these particles atoms. Now, there are various different ways that atoms can be organized. If we put more than one atom together, and we call that bonding the atoms together, we have what is called a molecule. Now, molecules can be of the same kind of atom, and we call that an element. Oxygen, for example, is an element. It has two atoms of oxygen bonded together. We call it O2 or oxygen. But if we take different kinds of atoms together and bond them into a molecule, we have a compound. And we as life scientists are very interested in looking at what we call organic compounds. So let's have a look at this idea in a little more detail. We've said that when you take atoms of different elements and you combine them together to get molecules, you can get very, very simple molecules. Water, for example, is one that you're probably the most familiar with. One oxygen atom, two hydrogen atoms, a very small molecule. It is also, by the way, an inorganic molecule. So hold on to that idea because we'll get to what an organic molecule is in a little while. Water, as we just said, is a very simple inorganic compound, but you can get molecules that are made up of thousands and thousands of atoms, very, very large molecules. We find that organic molecules tend to be very, very big. All living things are made up of molecules, and some of the elements that are in living organisms are also in non-living matter. We know that water is non-living, and we know that the bodies of living organisms, such as yourselves, have a great deal of water in them. So we find that although you do have inorganic molecules in you, you do have far more organic molecules making up living bodies. The most abundant, and that means the kinds of elements that appear most often in living organisms, can be summarized in this table. Carbon, written with a capital C, is the major element found in all organic molecules. You will not get an organic molecule that doesn't have carbon in it. Hydrogen, written with a capital H, is also a major element that is found in organic molecules. Oxygen, as we know, the molecule the substance that is essential for cellular respiration, is also found in a lot of organic molecules. Other elements that are found in great abundance in living organisms, nitrogen and sulfur. Nitrogen is a component of all proteins and nucleic acids, and sulfur is a very important element found in many proteins in your body. But of all these elements, definitely carbon is the most important, the major element that is found in the bodies of living organisms. And because of the presence of carbon being so important in living bodies, this has led to the emergence of a complete field of study called organic chemistry. So what makes an organic molecule? The important feature is that organic molecules will always contain carbon bonded to other carbon atoms in the molecule. You'll never find carbon bonded to just any other elements, always carbon-carbon, and the other atom, the other element that is important in an organic molecule is hydrogen. Very often you will also find oxygen, but your two important features, carbon-carbon bonds and carbon-hydrogen bonds. In an inorganic molecule, you'll never have carbon and hydrogen together in one molecule. So you can have water, which has hydrogen and oxygen, and for example carbon dioxide, which has carbon and oxygen, but you're not getting that combination of carbon and hydrogen together. Now, the cells of living organisms are made up of many different organic and inorganic molecules. We as life scientists are less interested in inorganic molecules and far more interested in organic molecules. And for the rest of our lesson today, we're going to be looking at some of these different types of organic molecules that you can see now on this mind map. Carbohydrates, proteins, lipids, and nucleic acids. And after the break, we'll focus once again on more organic molecules that we find in living organisms.